All right, I'm just going to walk through these questions on the Unit 6 review. So here we go. All right, our first topic was law of exponents. So remember, if you have a power on the outside of the parentheses, that power has to go to every single factor inside. It doesn't matter if it's a number or a variable, right? You have to give everybody that power on the outside. And if it's power to a power, then you multiply the powers, right? So that's exactly what I'm going to do. If you would like, I'm going to erase this. You could rewrite this so that, and give everybody the fourth or that -2 power. So if I put the negative x to the -4 in parentheses and put a -2 power on the outside, then I'm going to do the y to the -2, but give him the -2 power, right? Then I'm going to do the x to the -3 on the bottom and give him the -2 power. And then the y to the 5th on the bottom, he also has to get the -2 power. And then everywhere you have a power to a power, you multiply the powers. Okay, so my next step is going to be to clean up that mess I just made, right? So that's going to give us x to the -8th, y to the +4th, and then on the bottom, x to the +6th, and y to the -10th. All right, so now we've gotten rid of all the parentheses, which is awesome. Now we have to fix our negative exponents. So I'm going to come down here, and everybody that has a negative power means they are unhappy where they are, right? So that means that the y to the 4th in the numerator is perfectly happy where he's at, but the x to the -8th is not. So I'm going to move him down. Okay, and then in my denominator, this x to the 6th is perfectly happy in the denominator where he currently is, but this y to the -10th is not happy down there, so he's going to move up top. And now we're almost done. Remember, you're not completely finished until you have all of the like bases merged together. So in my numerator, I have 4 y's, and I'm adding 10 more y's to the chain of multiplication. So remember, when we multiply, we add the exponents. So that's going to turn into y to the 14th power. Because if we were to write that out longhand, we would have 14 y's, y times y times y times y, 14 times. And then same thing in the denominator, we're trying to merge all those x's together. So we have x to the 8th times x to the 6th. But when we're multiplying, we're just adding to the chain of multiplication. So x to the 14th power. And that would be our final answer. Okay, hold on, I got to wipe off my screen really quick. Okay, there we go. I thought it might shimmy my screen. All right, let's go to number 2. All right, so again, we have 3 factors inside, and they all have to get the 5th power. So here's what I'm going to do. -2, I'm going to put him in his own little parenthesis, and he gets the 5th power. Then the x cubed gets his own little parenthesis, and he gets raised to the 5th power. And then the y to the 4th gets his own parenthesis, and he gets raised to the 5th power. All right, now I'm just going to simplify each one of those factors as much as I possibly can. Now this first part, I can just literally type that in my calculator. So -2 raised to the 5th power, and that gives me -32. Please remember, if it's in parentheses on your paper, it must be in parentheses on your calculator. All right, so you can just type that in. And then, of course, here we have a power to a power, so we multiply the powers. And then here we have another power to a power, so we multiply the powers. And there's absolutely nothing that I need to do with this answer because there's no x's and y's to merge together, or like bases, I mean. And everybody's got a positive exponent. So, yeah, that's just our final answer after that one step. All right, number 3. All right, so this is a division problem. The very first thing I noticed about this division problem, however, is I do have a negative exponent. And he's the only thing that's not happy. So what the very first thing I'm going to do is I'm going to rewrite this entire problem, p cubed n squared over 5p m to the 5th n to the 8th. And I'm going to move those 6 m's to the denominator where they are now positive and happy because they're on the other side, right? That's what negative exponents mean. Okay, so now that I've fixed my negative exponents and now everybody's positive and where they want to be, now I'm actually going to do the division. Okay, so remember, these are just numbers, right? Numbers are just treated just like normal everyday numbers, right? What is 25 divided by, oh, sorry, he keeps shifting on me. Right? We're asking ourselves, what is 25 divided by 5, right? And 25 divided by 5 is 5, right? So we're going to end up with a 5 in the numerator. Then I'm going to reduce all of my other variables. You can use the subtraction rule if you want to, but I just kind of like to use the reduction rule. If we reduce 1p out of the top and the bottom, because the bottom only has 1 to give, then that would still leave us with 2 p's on top. And then I have 2 n's on the top, but 8 n's on the bottom. So I can now reduce 2 n's, which would leave us with 6 n's on the bottom. And the other thing I notice happening is in my denominator, I have 5 m's, and then I moved those 6 m's down below. So I'm going to be able to merge all those m's together. Okay, so let's talk about what we have left. So we have 5 because of the 25 divided by 5. We have p squared left on top. And then on the bottom, we have the m's, but I have 11 total m's because I'm going to add the 5 plus the 6, right? Because we're merging the m's together. And then we have the 6 n's, so n to the 6th. And that is our final answer after we clean up all the mess. All right, moving on. Number 4. All right, so on number 4, the biggest thing I notice is that this parenthesis doesn't have anything on the outside of it, right? So I'm just going to go ahead and drop that parenthesis and just kind of let him hang out there in the front. Now this parenthesis does have a 2 in outside the parenthesis, which means everybody inside has to get squared. So the 4 gets squared, the a cubed gets squared, and the b to the 6th has to get squared. And then it's my job to get rid of all of these parentheses. Well, 4 squared is just something I can do in my head or type in my calculator, right? So that gives me 16. And then I have a power to a power. So we multiply the powers. So that's a to the 6th. And then we have a power to a power on the b's, which gives us b to the 12th. So we got rid of all those parentheses, and now I'm just going to bring down that 3ab squared from the beginning. And now I'm just going to do this multiplication problem, right? We can multiply numbers times numbers. So 3 times 16 gives us 48. I can multiply 1a, remember there's an understood 1 right there. I can multiply 1a's times 6a's, but remember when we multiply, we add the exponents, so that's 7 total a's in our chain of multiplication. And then we have b squared and b to the 12th, and when we multiply, we add the exponents. So we end up with 14 total b's, and that is our final answer. All right, continuing, more exponents. Here we go. All right, so what jumps out at me about this problem? Currently, of course, all of this is in the numerator right now, right? All of that is in the numerator, but then I noticed that these guys are not happy because they have negative exponents. So what I'm going to do is I'm going to leave my z to the 4th y cubed up top. These guys, they're perfectly happy where they are, but these guys are all going to move down low. So z to the positive 9, y to the positive 5, after we make them happy by moving them to the denominator. And now, of course, I can reduce some z's and y's because I have some up top and some on the bottom. So it's just a matter of how many you can reduce. Well, as far as the z's go, the top has 4 z's to give up. So that means I can reduce 4 z's out of the top and the bottom, which leaves me with 5 z's on the bottom. And then I can reduce 3 y's because the top has 3 to give. But if I reduce 3 y's out of the bottom, that still leaves me with 2. And please don't forget there's always an understood 1 in front of everything. So even though I've canceled everything out of the numerator, I still have 1 up top to hold that numerator open. And then x to the 5th y squared would be my answer. Okay. All right, number 6, k to the 2/3 times k to the 4/11. Again, I know that's kind of a weird problem, but don't freak out when you have the fractions. You're just going to use the exponent rules. Remember, the exponent rules tell us that when we multiply, we add the exponents. Normally, I don't write it like this, but because it's a fraction, I'm going to go ahead and do that. And then if you don't know what 2/3 plus 4/11 is because you need a common denominator to add fractions, then please do it on your calculator, right? Use your fraction mode and type in 2/3 plus 4/11, right? And it's going to tell you that it's 34/33. And we're just going to leave it like that. I know that looks gross, but we're just going to leave our answer like that because we know that we're just going to add the exponent or add the 2 exponents, and that's what we're going to get. Okay. Moving on. All right, this is another one that's Checky fractions, but that's okay. Normally, I would do the reduction rule when I see a division problem, but in this case, I am going to use the subtraction rule, right? So when we divide, we subtract the exponents, right? So 9/4 minus 5/4. And if you do 9/4 minus 5/4, you get 4/4, right? Actually, no one's going to write that. So I'm just going to write v to the first power or just v. Right? I would take it written either way. Okay. All right, number 8. This one's kind of weird. They all have like bases, but all of our exponents are letters instead of numbers. I find this one to be odd, but that's okay. We're just going to use our exponent rules. The first thing I want to point out is that this guy's a fraction and this guy isn't. Well, what I always like to make everybody matchy. So I'm going to make this guy a fraction by putting him over 1. And then when we multiply fractions, we multiply straight across. So my first thing I'm going to pay attention to is that this is just going to be t to the a times t to the c all over t to the b, right? I want to merge it all together and just make it one giant fraction. And this question is really just a lesson on knowing your rules. I do have like bases, right? Everybody's a t, which means I should be able to merge this down to just one t by asking myself, what do I do with the exponents? Well, what do I do when I multiply? You add the exponents, right? So this is going to give me t to the a plus c. And then I'm going to go ahead and I'm doing this in kind of baby steps. And then I'm going to keep that t to the b power. Well, I still have like bases, so I should still be able to merge these together. And what do we do with the exponents when we divide? We subtract. So I'm going to keep my t to the a plus c, and I'm going to minus the b. And that is my final answer by merging all the t's together by using the exponent rules. That's kind of a weird one. All right. Oh, it looks like we've got a few more. Here we go. All right, this one kind of looks familiar. It's very similar to one that we just did a few minutes ago. So the first thing I happen to notice is that I have a lot of unhappy exponents, right? So everybody that has a negative power, I'm going to move him to the other side and make him happy. And everything else, everything that has a positive power is just going to stay put. So the 12 is going to stay. The b to the 6th is going to stay. The 4, a to the 5th, a c to the 5th. So that's everything that had a positive power that's not highlighted. So they're going to stay put. Now I'm going to move everything to the other side. So the a to the 1st is going to come down. And then the c to the negative third is going to come down and they become positives. And then that b to the negative 1 moves up top where it becomes b to the positive 1. All right, so now everybody's happy and they're where they're supposed to be. So now I can start simplifying. Well, again, please don't forget, numbers are just numbers. They just get treated like a normal division problem. And 12 divided by 4 is 3, right? So I'm just going to do the division. That gives me 3. All right, then I happen to notice, I'm going to go ahead and draw myself a new division bar here. So here's my 3. And then I notice up top I have 6 b's, but I joined one more b with it. So when we multiply, we add the exponents. And then I happen to notice in the denominator, I had 5 a's and I brought one more a down. So when we multiply, we add the exponents. So that gives us 6 total a's. And then I brought those 3 c's down to join the other 5 c's that were already down there. And when we multiply, we add the exponents. And that's our final answer because we've merged all the like bases together. And voila. All right, let's go to number 10. Number 10, everybody gets the 5th power. The biggest mistake I see from students is they only give the variables the x power, but every factor inside has to get the x power, even the 2 and the 3. So when I rewrite this, the 2 gets the 5th power. The x gets the 5th power. The 3 gets the 5th power. And the y gets the 5th power. All right, so I'm just going to write it like this first because visually I just want to make sure I've given every single factor inside the 5th power that's on the outside. And then I'm just going to use my calculator to help me clean that up a little bit, right? So I already know 2 to the 5th power is 32 because we did that earlier. And then, of course, x to the 5th is just x to the 5th. And then I'm going to use my calculator and just type in 3 to the 5th power, which is 243. And then, of course, y to the 5th is just y to the 5th. Now, if I could reduce the 32 over 243, I would, but it is not reducible. So that's my final answer. All right, number 11. All right, very similar situation. Everybody on the inside has to get the negative 2 power. So I'm going to do exactly what I've been doing, right? So the 2 inside, he gets the negative 2 power. The x squared gets the negative 2 power. The 5 gets the negative 2 power. And the x cubed gets the negative 2 power. All right, so I'm going to clean this up a little bit. So let's see, that's going to give me 2 to the negative 2, which I'm just going to leave that like that for now because he's not happy. And I don't want to type that in my calculator, even though I could. I'm not going to type that in my calculator because I don't want to do that until he's a happy exponent. Okay, so we'll deal with him in just a second. And then we have a power to a power. So we multiply the powers. And then same thing on the bottom, 5 to the negative 2. Again, I could type that in my calculator, but he's not a happy exponent yet, so I'm going to wait. And then over on my x's, I have a power to a power, so multiply the powers. So you'll notice we ended up with a lot of unhappy. Everybody's unhappy, right? Every single factor is unhappy where they are, which means I'm going to flip the entire thing, right? So the 2 squared and the x to the 4th, they're going to move to the denominator, right, where they become positive because they didn't like it up in the numerator. So they become positive powers when we reciprocate it and move it to the other side. Same thing with our denominator. We're going to move those 2 factors to the top where they become positive and happy. And now that everyone is exactly where they want to be, now we can type it in our calculator and get all of our final numbers. So 5 squared is 25. 2 squared is 4, so we end up with 25/4. But then I do notice that I have x's on the top and the bottom. So that means I can reduce some of the x's. And it looks like I can reduce out 4 of the x's, which is going to leave us with 2 x's. Or, of course, you can use the subtraction rule, which gives you the same answer, of course. And that is our final answer. All right, got a couple more to go. All right, let's see. The first thing I notice on this one is I have some parentheses. So I've got a power to a power. So I'm going to multiply the powers. Now, I'm not going to do anything to anybody else. I'm just going to literally bring everybody else over. The only thing I'm going to fix is that power to a power on the y. So we multiply the powers. Remember, I like to just do one step at a time to make sure I'm not doing too much at once and making a silly mistake. Okay, so step number 1, I got rid of the parentheses by multiplying the powers. Step number 2, I definitely notice I have some unhappy negative exponents. So again, I'm going to completely rewrite my entire problem. The 4 and the 8, I'm just going to keep where they are. The y to the 4th on the top is perfectly happy, and the x cubed on the bottom is completely happy. But what's not happy is that x to the negative 2, so I'm going to move him to the bottom. And the y to the negative 6 is unhappy on the bottom, so I'm going to move him to the top. All right, so we got rid of the parentheses. We got rid of the negative unhappy exponents. Now we can actually start getting somewhere and simplifying this fraction. So the first thing I'm going to handle is the numbers because it's just a division problem. So if I saw 4/8, what would I do? Well, I would reduce that to 1/2, right? 4/8 is 1/2. And then the other thing I notice is I have all the y's on top now, and when we multiply, we add the exponents. And same thing with the x's. All the x's are in the denominator. And if we want to merge those together, we're going to add their powers. So that makes our final answer 1y to the 10th. I'm not going to put the understood 1, but you're more than welcome to if you want to. And then on the bottom, we have 2x to the 5th because there's 5 total y's. And that is our final answer. All right, number 13, where it says write v cubed as a product, which means to multiply, of 2 powers with the same base in 4 different ways. Oh my gosh, using positive, negative, or 0 exponents. Okay. So v cubed as the product of 2 powers. Okay, well, let's see. I know v times v squared would give me v cubed, right? Because when you multiply, you add the exponents, and there's an understood 1 right there. So that would give me v cubed. So that's a product of 2 powers, giving me v cubed. Let's see. What if I did v cubed times v to the 0? Well, remember, anything to the 0 power is just 1, so that would just give me 1 times v cubed, which is v cubed. Plus, we add the powers, and 3 plus 0 is still 3. Let's see. I could use fractions, I guess, if I wanted to. I could do v to the 3/2 times v to the 3/2, which gives me 6/2, which is 3. Right? So I could use fractional exponents to get me there. I could also use negative exponents. What if I did 5 to the 3rd v to the 5th, I don't even know what I was saying, times v to the negative 2. All right, so I've got a negative exponent. I would still add, and it would still give me v cubed. Again, we could write these all day long. There's like an infinite number of math problems we could create that would give us v cubed, right? So this is just kind of off the top of my head what I would think of. All right, and let's see. I'm going to go up here to our very last one. This is the one that's asking us to find the missing power right here. So let's see. We know we're going to add. So it's basically, sorry, I'm trying to highlight here. So we have x to the 5th and x to the 8th, which gave us x to the 13th, right? And then we have y to the what times y to the negative 6 gives us y to the 22nd. Well, we know we should be adding those, right? So it's going to be question mark plus negative 6 equals 22, right? What number plus negative 6 gives us 22? Well, this is just a one-step algebra equation, right? We know that we can just add the 6 to the other side to move him over there, right? So that would give us 28 for the question mark. And that makes sense, right? If I put a 28 right there, 28 plus negative 6 would give me 22. All right, so pretty easy. We can just do that in our head. All right, moving on to the third section in our unit, which was simplifying radicals. Please make sure that you don't ever give me decimals, right? I've had a few of you guys just typing the square root of 402 in your calculator and giving me some rounded or infinite decimal kind of answer. And that is not what we want here. We want exact form, which means leaving it as a square root. Okay, so here we go. So 402, I'm going to make myself a prime factor tree. And again, use your calculator. You can just clearly this is an even number. So I'm just going to start with the number 2. So I'm going to divide 402 by 2, which gives me 201. So just pick any two numbers that you know go into 402. It doesn't matter what you start with. But I am going to circle my primes once I finish that branch. Now 201 is not done, right? That is divisible by 3. So that goes in 67 times. Now 67, I'm trying to think if any numbers go into 67, and I can't think of any numbers that do. Okay, so I'm pretty sure that's a prime number, right? So that's prime. Well, remember, when you are trying to simplify radicals, you're looking for a pair of numbers. And it doesn't look like in all my primes, I don't have any pairs. Like I don't have a pair of 2s, a pair of 3s, or a pair of 67s. So that means my answer is not or my question is not simplifiable, which means my final answer is just the problem that I began with. It's just the square root of 402, because there are no pairs that I can use to simplify that square root. Okay, so you just leave your answer as the square root of 402. All right, let's go move on. 3 square root 25. Well, 25 is awesome, of course, because it's a perfect square, right? So when I do a factor tree, obviously it's 5 times 5, and anytime I see a pair, right, that means I get to take that pair out. Now, there's nothing else other than the pair, which tells me it's a perfect square. So the square root of 25 is 5. So I'm taking out the 5. I'm multiplying it by the 3 multiplier that was already hanging out in front. So my answer is 15. And it is a nice perfect whole number. So if you want to check that, just type it in your calculator. You totally could. All right, let's go do this one. So this is a multiplication of 2 radicals. So remember, you can only multiply outside numbers times outside numbers. So I'm going to do that first, right? So 7 times negative 9 gives me negative 63. And then I'm going to multiply inside numbers times inside numbers. So 12 times 3 gives me the square root of 36. Now, a problem that I noticed on your homework assignments is a lot of you guys just stopped here. Like you just multiplied like you were supposed to, which was good, but then you just stopped as if that was the end of the problem. But that's usually not the end of the problem, because by multiplying the numbers underneath the square root, you're creating a bigger number. And that bigger number is probably simplifiable, right, by making a factor tree. And 36, of course, is a very special number because it's a perfect square. Right, so, and I think most of us know that 36 is a perfect square because it's 6 times 6. So that means I can actually keep going and just simplify the square root of 36 as 6. And then I can type that into my calculator and figure out that negative 63 times 6 is negative 378. And again, because that one was a nice whole number, if you wanted to, you could just check your work by typing that entire problem in your calculator and seeing if you get negative 378. Okay. All right, same exact thing on number 18, right? There's an understood negative 1, right? So when I multiply negative 1 times the 2 that's in front of the other guy, right, that's going to give us negative 2. And then square root, because we're going to multiply the 6 underneath that radical times the 32 times that radical, and that gives us 192. But again, don't stop here because we created a really big number underneath the square root and it's probably simplifiable. So I'm going to go off to the side over here and I'm going to make myself a factor tree. 192 is not a perfect square, but that doesn't mean we can't find any pairs that come out. So let's see, it's an even number, so I know 2 goes in there. So 192 divided by 2 gives me 96. And this is prime. All right, I'm just going to stick with 2 because it's another even number. So I'm going to divide that by 2 and I get 48. Circle that 2. That's another even number, so I'm just going to keep rocking with the 2s. And that's another even number. Lots of even numbers going on here. I'm going to, hold on, let me scooch this up a little bit so I don't run out of room. Let's see, 2 times 6. I may as well just keep rolling with the 2s. And then 2 times 3. Man, that is a lot of prime numbers going on. So it doesn't matter how you break this down. We should all get 6 2s and a 3. Okay, so what does this mean? Well, I have a pair, I have a pair of 2s. Okay, so let's go back to the problem over here. First of all, I have the -2 multiplier that was already hanging out front. So I'm just going to go ahead and bring him down. I have a pair of 2s right here, which means I get to take out a 2 to represent that pair. Feel free to cross it off if you want to once you've pulled it out. I have another pair of 2s, so I'm going to take out another 2 to represent that pair. Then I have another pair of 2s, so I'm going to take out another 2 to represent that pair. And then, of course, my lonely little 3, right? He doesn't have a buddy, which means he has to stay inside the square root. And, of course, I need to clean up that mess. -2 times 2 times 2 times 2. That's going to give me -16 root 3. And that should be my final simplified answer. Okay, number 19. The length of a rectangle is 8 root 2 and the width is 5 root 3. Find the area. Okay, well that's a pretty easy problem because we know area is just length times width. So all they're asking us to do is multiply 8 root 2 times 5 root 3, which is literally the exact same question we've just been doing the last couple rounds, where we have numbers on the outside that we multiply and numbers on the inside that we can multiply. Right, and so when we do that, we get 8 times 5, which is 40, and 2 times 3, which is 6. Now, technically, this is going to be my final answer because when I go off to the side, 6, of course, is just 2 times 3, so there are no pairs in the number 6. So there's nothing that can come out of the radical in this case. So that is going to be our final answer. All right, so then we moved on to day 4, which is multiplying polynomials. All right, so remember we talked about that you could either do the box method or you can do the double distribution method. I'm pretty much just going to do the double distribution method. I might do one box method just to refresh your memory on that if you'd like. All right, I'm going to do double distribution here. So we got to take the 3t and he has to get multiplied times everybody in the other parenthesis. So let's see, 3t times -2t gives us -6t squared. Please don't forget, when you multiply a t times a t, you get t squared, because when you multiply, you add the exponents, right? So t1, t1, so that gives us t2. All right, then I'm going to distribute the 3t to the -4. So 3t times -4 is going to give me -12t. All right, so that's our first distribution. Then we have to distribute the +9 and multiply him times both of the terms over there. So +9 times -2t is going to give us -18t. And 9 times -4 is going to give us -36. So notice we have a 4-term polynomial, which should always happen when you multiply a 2 by 2 or a binomial times a binomial. And of course, you're not done until you've combined any like terms, which usually occur in the middle. Just kind of depends on the problem that you have. So if I combine -12t's with -18t's, that gives me -30t's. And then I'm just going to bring down my 36 and my -t squared. And that is our final answer. All right. Number 21, expand the expression. Please make sure you understand that this 2 on the outside, you are not allowed to distribute him to the stuff inside because the stuff inside is terms and not factors. So if you see 4x plus 3 squared, you actually have to write that out as 4x plus 3 times itself, because that's what it means to square something, is to multiply it by itself. Then it says to simplify that expanded expression, which means to get rid of the parentheses. I'll do the box method on this one, just to refresh your memory if you prefer that method. So it's a 2 by 2 term multiplier. So I'm going to make a 2 by 2 box, and I'm going to put 4x plus 3 along the top and 4x plus 3 along the side. And then I'm just going to multiply the tops and the sides to get the value in each box. So here we go. So if I multiply 4x times 4x to get the top left box, that gives me 16x squared. And then positive 3 times 4x is going to give me positive 12x. And in the lower left box, I'm going to multiply the 4x and the positive 3 again, which is going to give me another positive 12x. And then the last box is going to be 3 times 3, which is 9. And I always like to put the plus or minus signs in the box. Now, the cool thing about the box method is that your like terms should always lie along this diagonal, right? And so it's a nice way to kind of group your stuff together. So the 16x squared, but then if I add my like terms along the diagonal, there means 12x plus 12x, which is 24 total x's. And then I can bring over the plus 9. And that would be our answer. And of course, you'd get the same answer if you did the double distribution or the FOIL method. All right, let's see. I'm heading back up here. Okay. John needs to find the area of a rectangular parking lot. Okay, so this one says to draw the picture. So I'm going to go ahead and do that. So I'm going to draw a rectangle. To determine how many parking spaces he can paint in the lot, he knows the length is 5g minus 1. Okay. And the width is 3g plus 6. Find the area. Okay, well, we just talked about this over here, right? Area is just length times width. So we know that the area of the lot is just going to be 5g minus 1 times the 3g plus 6. Again, if you want, you can use the box method, or you can just use double distribution, which is what I'm going to do, but whichever method is fine. So I'm going to distribute the 5g and multiply him times everybody over there. So 5g's times 3g's gives me 15g squared, and 5g times 6 gives me 30g. Then I'm going to distribute the negative 1, which gives me negative 3g minus 6. And of course, there's my like terms, my g's hanging out in the middle. So that's going to give us 15g squared plus 27g's when we combine the 30 and the negative 3. And then I'm going to bring down the minus 6. And this is the expression that would represent the area of the parking lot. Now, C is kind of tricky because we haven't talked about perimeter, and a lot of people mess up. They confuse perimeter with area. So remember, area is always just length times width. Perimeter means to add up all the sides. So if I were you, I would actually draw the picture and label all 4 sides. So whatever you can do to visually help yourself through the problem. So both my lengths are 5g minus 1. And both of my widths are 3g plus 6. So remember, perimeter means to add all of the sides, right? So I'm literally going to do 5g minus 1, 3g. I'm going to stack it because I don't have enough room to write it horizontally. Sorry, I know that looks kind of weird. So we're going to add all 4 sides together, right? That's perimeter, adding up all the sides. And I just stacked it like this because I can only add like terms. And this way, all my like terms are just kind of stacked vertically. So let's see, 5g's, 3g's, 5g's, and 3 more g's. It looks like that gives me 16 g's total. And then negative 1 plus 6, negative 1 plus 6. Looks like that gives me 12 minus 2, so positive 10. So this is the expression that would represent the perimeter of the parking lot. Okay, so make sure you keep those 2 different formulas straight. right? Area is length times width, right? And perimeter is to add all the way around. All right, we're getting to our last section of factoring polynomials. So remember, there's two different ways to factor. Number one, GCF, and number two is to factor by grouping. And that's if it's a quadratic trinomial, okay? So those are the only two types of factoring that we'll be using. Okay, so number 23 is just a binomial. So if it's a binomial, then I'm just going to factor by GCF. So what do these two terms have in common? They have an x in common. So I'm going to take out the x. And in parentheses, we're going to write down what's left. But remember what that means is we're dividing the x out of each term to figure out what's left. Well, if I take 1x out of 3x squared, well, there's 3x left. There were two x's, but I took one out, so there's only one x left. And then, of course, here the x's cancel, so there's only a 4 left when I take his x out. That's it. That's all I can do is just take out that GCF of x. All right, I'm going to hop to our last page here. Now, number 24 is a quadratic trinomial, so I'm going to factor him by grouping, right? So remember, it's a 3-step process, right? We talked about this a lot in class, so there's an understood one. So the first thing we do is we create our number puzzle, and we multiply the A times the C, which gives us positive 9. So we want the only two numbers in the entire world that multiply to give us positive 9, but adds to give us positive 6, that B term in the middle. Again, if you don't remember these steps, please go back and look at your notes. They're very much typed out in your notes, right? How to do this step by step if you have forgotten. So then you can go to your calculator. If you don't know what factors of 9 add to give you 6, I'll just give you a little refresher here. Let me go to, here we go, so remember you go to your y equals. Let me clear this all out. Okay, so you're going to do, since we're looking for factors of 9, I don't know why that won't go up just one. Ugh. There we go. So you're going to do 9, sorry, I got to scroll up, divided by x on line 1. Then you're going to hit enter and go to line 2, and you're going to type in the exact same thing, 9 divided by x, but then you're going to do plus x. Right, and this is how we can get our calculators to help find our factors for us if you can't do it by hand. Okay, so then I'm going to go to my table, which is second graph. And my goal is to go find the 6 in the red third column. Right, and you can see right there on that fourth line down, it says 3, 3, 6, which means that my answers are 3 and 3. Those are the two factors that add to give me 6, but multiply to give me 9. Okay. So that means that it's 3 and 3. And it's important that we find those two numbers because remember, that's how we got this 6K in the first place, was with a positive 3K plus another 3K. And then we bring down our first and last term, and voila, we've turned our 3 terms back into its original 4-term state. And then once you get here, this is the hardest part, right? Once you get here, you're pretty much home free. You're just going to split it down the middle, and you're going to do the GCF 3 times in a row. So the GCF of the left 2 terms, the GCF of the right 2 terms, and then the GCF of the binomial that you've created. So here we go. It looks like our first 2 terms only have a K in common. And if I take out a K, which remember, taking out a K means we're dividing the K out of each term. So that leaves us with K plus 3. And then for the second half, 3K plus 9, they have a positive 3 in common. So we're going to divide out the 3 from each term, which leaves us with K plus 3. And remember, your parentheses have to be identical at this point. If they are not, then you've done something wrong. I'm going to put my little signature happy face right there because this is my self-checking line that tells me that I'm totally on the right track, which means now I can take out the K plus 3 that they have in common. And once I divide out the K plus 3, it looks like K plus 3 is my leftovers. And so that is my answer. Now I do happen to notice that my parentheses are identical in my answer. So if I want to, I could write this as k plus 3 squared. You don't have to though, but I'm just pointing that out if you wanted to. Okay. All right, number 25. You have two options on number 25. You have the long way and you have the short way, right? The long way would be to recognize that there is no V term in the middle. So you can make a V term by just making it a 0V. And now you're right back to what we just did on this whole problem. It's absolutely no different, right? You're going to multiply the 16 times the negative 9, and you're going to ask yourself, what are the factors of negative 144 that add to give you the 0 in the middle? So you can totally work that the long way. I'm not going to, however. I want to refresh your memory that this is a very special binomial, right? And I know it's special because 16 is a perfect square, V squared is a perfect square, 9 is a perfect square, and it's a subtraction problem. So this is what we call a difference of two squares. We talked about this in class. It has a special formula. It is on your formula chart, which says if you notice something is a difference of two squares, you should just be able to hop directly to the answer without having to do any of that work. If you want to do the work, great, right? You're going to get the exact same answer that way. But what I notice when I'm like, ooh, a difference of two squares, that means I can just hop right to my answer by taking the square root and asking myself, what times what gives me 16V squared? Well, I know that's 4V. So I can put my 4 V's in the front. And then 9 breaks up into 3 times 3. And then, of course, I know my signs have to be, one has to be positive and one has to be negative, because that's how we cancel out and get a 0V in the middle in the first place. And that's my answer, all because I knew it was a difference of two squares. If you're not going to catch on to that, or if you don't see that automatically when you look at 16V squared minus 9, then please just do it the long way and insert the 0V in the middle and just work it like a normal factoring problem. Okay? All right, here we go. Number 26. The first thing I happen to notice about number 26 is that all of these numbers are even, which means there is a GCF of 2 that can be taken out of that entire trinomial. Now, if you don't see that at first, that's okay. Hold on, give me one sec. Okay, sorry. If you don't notice the GCF at the beginning, then you just need to remember to see it at the end. Okay, we talked about that in class a lot. All right, so I did notice that there's a 2 that all of these have in common. So I'm going to take out the 2, which remember means that we're dividing all of these terms by 2. Okay, so that's going to give us 6m squared minus 11m minus 2. And now this is the quadratic trinomial that we're going to factor by grouping. So I'm going to get my little number puzzle set up over here on the side. Okay, so I'm going to multiply the 6, the a times the c, which is now 6 and negative 2. So that's negative 12. So I'm looking for the only two numbers in the universe that multiply to give me negative 12, but add to give me this negative 11 in the middle. And you can pause the video if you'd like and go check your calculator out. But I know that that's going to be negative 12 and 1. So that means that this negative 11m was created from a negative 12m plus 1m. You don't have to put the 1 if you don't want to. And then I'm going to bring down my minus 2 and my 6m squared. And yay, I've turned my trinomial back into its original 4 term, only so I can split it down the middle and take the GCF of each half. So it looks like my first two terms have a GCF of 6m. So I'm going to divide the 6m out of each term, which is going to leave us with 1m minus 2. Now on this half, the only thing these two guys have in common is a 1. So I'm going to take out a positive 1. And that means I'm going to divide everybody by 1, which isn't going to change anything. That's going to leave me with m minus 2, which is awesome for me because that gives me identical parentheses, which I totally have to have at this point. So my happy face, yay, which gives me m minus 2 as the new GCF. And then the leftovers are 6m plus 1. But of course, I don't want to forget the 2 that we took out from the very beginning as a GCF, and that all 3 of those factors are our final answer. Again, if you forgot to take the 2 out at the beginning, then you would have noticed one of your parentheses having a GCF of 2 at the end, and you would have need to catch that and or caught that and put the 2 on the outside. Okay. All right, almost done. Number 27. Now, again, I noticed that there's a 2 in common again. I'm going to work this one, though, as if I just didn't see that. And just so you can see again, I know we did this in our notes, but I want you to see again what that looks like if you happen to forget to take the GCF out at the beginning. It's not a big deal. You just have to make sure you see it at the end. So I just want to show you what that looks like. Okay, so let's say I totally forgot to take out the GCF, or I just didn't see it, which happens. I do that all the time. So I'm going to go ahead and multiply my A times my C, which gives me positive 120. So I want the only 2 numbers in the world that multiply to give me 120, but add to give me 22. Now, if you don't know that off the top of your head, then again, I'm just going to hop over here. I'm going to go to my y equals. I'm going to type in 120 divided by x. And then on my next line, I'm going to type in 120 divided by x plus x. Right, whatever number's in the top of your number puzzle, that you just use that same number on both lines. And then I'm going to go look at my table, and I'm looking for a 22. And yay, it's at the very, very, very bottom of the table. So that 22 in my red column at the bottom, which tells me my 2 magic numbers are 10 and 12. So now I can go back over here, and I know 10 and 12 are my 2 answers. So I know this 22R was created from a positive 10R plus 12R. And then I'm going to bring down my 2R squared plus 60. And yay, the hardest part is over, right? I've turned my 3 term back into his correct 4 term. And now I can just split it down the middle and GCF. So let's see, it looks like my first 2 terms have a 2R in common. So I'm going to divide out the 2R from each term to see what's left. And it looks like that's going to give me R plus 5. And then on the second half, 12R plus 60. Looks like they have a 12 in common. So I'm going to divide by 12. And that's going to give me, oh, what do you know? R plus 5. I do a little happy dance with my smiley face because my parentheses are identical, which means my 2 factors are R plus 5 and 2R plus 12. Now, this is what I was talking about, right? I'm not going to box this up as my final answer because something should catch your eye, and this should catch your eye right here, that one of your parentheses has a GCF still, which means, oh yeah, I didn't take the 2 out at the beginning that I noticed now, right? So I'm going to catch it at the end, and I'm clearly going to take the 2 out. That'd be 2R plus 12, which would leave me with R plus 6 if I divide both of those by 2. And then, of course, I'm going to keep that R plus 5. He was fine the way he was. And that is going to be our final answer. Okay. Some people like to wait until the end every time because they forget to bring down the GCF from the beginning down into their final answer. And that's totally cool, right? If you want to do it this way all the time, there's nothing wrong with that. You just have to make sure you see it. All right, coming up here for our last few questions. All right, 4b squared plus 36b minus 40. Now, I'm not going to leave the GCF alone on this one. If you want to wait till the end, you totally can. But I do notice that all of these terms have a 4 in common. And I like taking my GCF out at the beginning because it makes my numbers much smaller and easier to deal with. So if I take out the 4, that just leaves me with b squared plus 9b minus 10. And now I can just work with that much, much easier trinomial. So if I multiply, there's an understood 1 now in the front. So 1 times negative 10 gives me negative 10. So I want the two numbers that multiply to give me negative 10, but add to give me positive 9. Well, that's going to give me 10 and negative 1. And again, you can go check that on your calculator if you need to. All right, so that means that I got this 9b from a positive 10b minus 1b. And then I'm going to bring down my minus 10 and my b squared. And yay, there's our 4-term polynomial. Again, it's the same 3 steps over and over and over again. It just takes practice. Once you get the hang of it, you'll never forget. So it looks like my first 2 terms, the way I wrote it, have a b in common, which if I take out 1b, that leaves me with b plus 10. Now over here on this side, they don't really have anything in common other than the negative 1. And yes, you do have to take out the negative 1. Right? If this half starts with a negative, remember, we never want our parentheses to begin with a negative. And if you just took out a 1, then you would have to put a negative b here, and we don't want that. So we have to take out a negative 1, which is going to give us b plus 10. Because remember, we're dividing everything by the negative 1, and that negative divided by negative is how we get that positive 10. And we knew it had to be a positive 10 because we know our parentheses need to be identical. Right? So now I have my happy face because my parentheses are the same. So b plus 10 and then b minus 1 with the leftovers. And then, of course, I don't want to forget the 4 GCF that I took out at the beginning. All right. Last few questions. Number 29. Let's see. 3, 20, and 87. Those do not have a GCF, right? And so I'm just stuck working with these really big numbers, which is totally fine because my calculator is going to do a lot of the work for me, right? So I don't know what 3 times negative 87 is. So I'm going to type that in my calculator. Oops, I accidentally hit divide. So 3 times negative 87 is negative 261. All right, so I'm going to go do my little number puzzle. I want the two numbers that multiply to give me that negative 261, but combine to give me the negative 20 in the middle. I have no idea what that is. So I'm going to go to my calculator. So it was negative 261, right? I'm going to go back to my y equals, clear it. Negative 261 divided by x. Okay, then I'm going to clear this one. And negative 261 divided by x plus x. So that's where I'm going to put on my calculator. And what was I looking for again? 20. Okay, so I'm going to go hit second graph to go look at my table. And I need to go find positive 20. So I'm going to scroll up. And it looks like there it is on my 3rd line down. I see 20, and that means my two numbers are negative 9 and 29. Negative 9, write that in, negative 9 and 29. Ooh, that's not right. It was negative 20. That means it's backwards. Sorry, I thought it was positive 20, but it was negative 20. Again, that was actually already on my screen. Let me just go show you really quick if I scroll down. Sorry, for some reason I thought it was positive 20. Right there it is, right in the middle. Do you see negative 20? I can't point to it on the screen. So you can see it was 9 and negative 29. Okay, sorry about that. All right, so that means I now know how that negative 20p was created with a positive 9p and a negative 29p. And then I can bring down my 87 and 3p squared. And yay, the hard part is over. We've got the 4-term polynomial. So now we can just split it down the middle and start GCFing each side. So it looks like the left side has a 3p in common. So we're going to divide out the 3p to see what's left over. And it looks like that should leave us with p plus 3. Now, if you don't know what the GCF of 29 and 87 are, use your context clues. All right, we already know this parenthesis has to be p plus 3, which clearly means that we have to take all negative 29 out. Right, so just use your context clues, or you can just use your calculator to help you out. I'm going to take out the negative 29. Right, and of course you can check that on your calculator. I'm going to divide out the negative 29. And what do you know? That leaves us with p plus 3, which we knew we had to get anyway. All right, so I do my little happy dance. And please make sure you just don't just write the identical parenthesis, right? You need to actually make sure that mathematically it is happening. All right, I'm just kind of using that to help me figure out my GCFs if I'm not quite sure. All right, and so now I take out the p plus 3 they have in common, and if I divide out the p plus 3, looks like that leaves me with 3p minus 29. And that should be my two final factors. All right, number 30. Find an expression for the length of the side of a square with an area of 9n squared plus 30n plus 25. Okay, so we're talking about area of a square. So that means we're trying to find the length times the width that gave us that in the first place. So don't get all confused by the fanciness of the word problem, right? They are literally just asking us to factor this trinomial, okay? I don't see a GCF, so I'm going to go ahead and multiply against some big numbers, but that's okay. We got a calculator to help us out. All right, so 9 times 25 gives us 225. So I need to find the only two numbers that multiply to give me 225, but add to give me that 30 in the middle. Well, I already know the answer to that is 15. Because it's a square, which means my numbers have to be the same, and 225 is a perfect square. If you don't catch that, that's totally fine. Just go use your calculator and type in your 225 divided by x, right? And it'll tell you that it's 15 and 15. So we know that this 30n was created from a positive 15n plus another 15n. Bring down our outside stuff. And yay. We've got our 4-term polynomial, so now we split it down the middle, and let's start GCFing. So it looks like my first half, 9 and 15, they have a 3 in common. So I'm going to take out a 3n. Oops, sorry about that. So I'm going to divide by 3n, so be careful here. 9n squared divided by 3n is going to leave us with 3 n's. And then 15 divided by 3, that's going to leave us with 5. So 3n plus 5. And then on the other half, we've got a 15 and a 25. Well, it looks like those have a 5 in common. All right, so we're going to divide out the 5. And that's going to give us 3n plus 5. Yay! All right, identical parentheses, which means I can take out the 3n plus 5 from each term, which leaves us with 3n plus 5. And I knew that was going to happen because they told me in the very beginning of the question that it was a square. Well, what do we know about squares? Well, squares have the same length and width, right? That all their sides are congruent. So it makes sense that I got identical factors there of 3n plus 5 and 3n plus 5. All right, our last one is a division problem. All right, so please remember, please don't try to start canceling out stuff. These are terms, right? And I said this in class, but I'm going to say it again. You can't, I'm just going to write it down because it's that important. You can't cancel terms, right? Terms are bound together by plus or minus signs. So even though I see a 4 and a 2 here, I can't touch those. I can't divide 4 by 2 because this 4 is bound to all these other terms and this 2 is bound to the end. So I cannot pick them out and just treat them as individuals because they're not, because they're terms, right? You can't cancel terms. Remember, you can only cancel factors. Factors and terms are very different, right? If I saw like 2x over 4y, well, then I can reduce them because those are factors. There's no plus or minus signs. So those are all independent little factors, right? But as soon as you start seeing plus or minus signs, you cannot start canceling stuff out. Okay, so that means I need to change this trinomial. Instead of terms, we need to turn it into factors. So that's the first thing I'm going to do is I'm going to go off to the side and I'm going to factor 3n squared minus 8n plus 4, which is what we've been doing for the last 15 minutes of this video. So I'm going to multiply, I'm going to make my little number puzzle. I'm going to multiply 4 times 3 which gives us 12. So we're looking for the factors of 12 that add to give us negative 8. And I do believe that is going to give us negative 6 and negative 2. So that is how we got the negative 8n by a negative 6n minus 2n. And then I'm going to bring down my outsides. So I'm going pretty quick because I feel like we've just done this a bazillion times at this point. So I'm going to split it down the middle. GCF 3n. That leaves me with n minus 2. Then I'm going to take out the negative 2. Don't forget you have to take out the negative if it starts with a negative, which also leaves me with n minus 2. So I get n minus 2 and 3n minus 2 as my two factors. So what I'm going to do now, I'm going to go over here and I'm going to rewrite the problem. So instead of that quadratic trinomial, I'm going to replace it with n minus 2 times 3n minus 2 because I've changed it into its factored form. And my denominator is n minus 2. Now, I know there weren't parentheses around it, but you can put parentheses around it if you want to. And now we're back to our rule right here. You can't cancel terms, but you can cancel factors. And now that I have an identical n minus 2 factor on the top and an n minus 2 factor on the bottom, now I can completely cancel the factors, which leaves me with 3n minus 2. And you can leave it in parentheses if you want, or you can take the parentheses away. It doesn't really matter. And so that is my final answer after I reduced the factors. And voila, there you have it, Unit 6. That's a lot going on, right? So please make sure that you're showing all of your work and that you come in for tutoring if you have any questions on any of these problems that we've just gone over here today, okay? All right, happy studying, you guys.